Hi there, this is Ian McTavish, and with Team 4152, this is our first training session for the 2024 season. So, Introduction to CAD. Before we begin, we want to make sure that we thank all of our sponsors. Our program wouldn't run without their generous support. And the goals for this session is we need to make sure all team members know how to navigate onShape and how to determine parts used in an assembly. And there is a link to the quiz, so we'll put that in the notes below this video so that you can easily take the quiz. And that quiz is your ticket to ensure that we know that you've completed the training. We'll also include this link. This is the link to the onShape document that we're using. You don't have to be logged in to be able to use it. Normally, we provide an account for all of our team members, but this allows anybody to access this model for the training session. So, what is CAD? CAD is an acronym. It stands for Computer Aided Design, and we use software to design our robot. The software we are using is called onShape. And the goal with being able to design in CAD is that it allows you to create all your parts and put them together and make sure everything's going to fit. And then when you're ready to manufacture parts, you can either export the parts so that it can be created, for example, on a 3D printer or on the CNC router, so that you can manufacture them, or you could export them as drawings and be able to give them to somebody. Maybe they're working on the lathe and they can take the drawing and go, okay, I need to cut this part to this length. And it gives us all the tools we need to be able to design our robot and make sure that before we're spending money on expensive materials, we have a design that we know is going to fit together nicely and is going to work. And we require everybody on the team to understand how to use some basic skills in onShape. So because we designed the robot in onShape, we want to make sure that when we are manufacturing our part, we don't have to wait for one of the CAD designers. We can be assigned the part and we know how to go in and either download the file or download the drawings. And when we're putting things together, we can pull up the design and be able to show, okay, this goes here, that goes there. So just some basic skills are required by everybody. So if you've clicked on the link, this is the gearbox that we are going to be using in onShape. And the first thing is that there's something called the tab manager. And this happens to be one of the questions on your quiz. So this little icon down at the bottom here can open and close this tab manager. And you can see at the bottom of the screen, all the tabs are listed there as well. But it's really important to be able to open and close this. When we use the tab manager, we can filter, we can organize by the different types of things in a document. So it makes it a lot easier to find what we're looking for. So Alt-T is the keyboard shortcut to be able to open up the tab manager. And as I mentioned, there's a typical document has lots of different screens. And so some of the tabs that we use are Part Studios. So that's where individual parts are designed. There's assemblies, and that's where you can see the parts put together so you can see how the mechanism goes together. And then there's also drawings, which we use to be able to have all the critical dimensions for when we're manufacturing something. We also include other things such as PDFs, and so the PDFs allow us to keep stuff organized as well. In the tab manager, you can also filter by different types of things. So the first thing that we're going to do is in the tab manager, we're going to click on this icon right here, and that will filter everything so that we're only looking at assemblies. And in this particular document, there's only one assembly, so we're going to just open that up. And this is the assembly. So this is a gearbox similar to one we used a couple of years ago. There's on the left, you can see all the different instances. So these are all the different parts that make up this gearbox. So the instances are really helpful. And what you can do is you can hold your mouse over it and you can see the full name and you can see an outline. So for example, I've held my mouse over this one so I can see it's the 14 tooth, the sim pinion gear. and it's highlighted there so I can see where the gear is in my model. I can also right click and get some options. So being able to hide and show instances is really, really useful. That way you can kind of see, okay, I see this, but what's behind it? What's holding it together? And by being able to hide things or isolate them or make them transparent, it allows you to really be able to get a handle on how everything goes together. And there's a link here. OnShape Health has fantastic little mini tutorials that allow you to quickly learn different skills. So it's really useful to take some time to explore the help. So here we've hidden the gearbox plate, and you can see we clicked on that little icon, so that is now grayed out, indicating that it's hidden, and we no longer see it in our model. And because we've got it selected, we can see the orange outline of where it is. So we can turn this back on by simply clicking there, or we can right click somewhere on the screen, and that will bring up a little mini menu, and we can choose to show all. I always pick show all instances because that will show all the parts. But in an assembly, we also have other things such as mate connectors and mates, and show all shows everything, which is more information than we typically need. So show all instances is really handy there. On the right side of the screen, you can see the view cube. And if you're in the model, the view cube is a great way to be able to change your view. You can click on one of the faces, you can click on one of the edges or one of the corners, and that allows you to change the view to look at that particular view. You can also see we have an X, Y, and Z axes on here. And those, if you look at the X axes, we always do the left-hand rule where if we hold our hand out, the thumb becomes our X, the middle finger goes pointing towards the Y, and then our index finger points to Z. And if we're standing in front of the CNC router, for example, that allows us to be able to figure out where the X is and the Y is, so that if we're trying to lay out a part based on a diagram, we know exactly how to lay it out. So those concepts are really important. In addition to the view cube, we can also use these mouse controls, and some of these are on the quiz, so pay attention to them. So the left mouse button allows us to select something. So if we have an item, we click on it, that selects it, that's the left mouse button. Now the scroll wheel, and this is really important. When you're using OnShape, I highly recommend you use a mouse. You can do these things with a touchpad, but the touchpad resolution is nowhere near as accurate as the mouse, so it's much easier to do it with the mouse. So the scroll wheel on the mouse allows you to zoom in and out, and this is based on where you're holding the mouse. So for example, in this slideshow, if I'm holding my mouse down over here by the logo and I zoomed in or out, it would zoom in on that logo. And if I held my mouse over here, it would zoom in on that text. So that's a really key thing, is it depends on where you're holding your mouse. If you hold the scroll wheel down and move it, this is called panning. And in the movie industry, when you have a camera going sideways, that's called panning. So we can kind of, if we think of a 3D program as kind of a movie, we're controlling the camera. So by panning, we can move sideways or up and down. And then if we hold the right mouse button down and move the mouse, we can rotate our view. So that's as if we're taking the camera and going around the object. We also have some other selections. So if you're wanting to select multiple items, you can left mouse click and drag, and that creates a rectangle that selects all the items. And even doing that in a slideshow, that allows you to select multiple photos if you have them in a slideshow. So these are common techniques in most software. And then holding down Shift while clicking with the left mouse button allows you to select multiple items. Now, if you are logged in, This icon is on the right of the screen in the assembly view. If you are not logged into OnShape, but you're looking at the model, then that icon shows up at the bottom of the screen. So this icon allows us to open up the bill of materials. And the bill of materials is basically a spreadsheet allowing us to view all the parts in an assembly. So these are all the different items. And you can see item number 8, we have a question, how long is it? So if you click on it, over in the instances section, you should be able to click on it and hold your mouse over it, and it will show you the full title. And we can't see it on the screen here, it's cut off, but we've got a 1032 times, and then the next number is the length. And so this allows us, the bill of materials is really useful because when we have finished a design, we finalize it, then we use the bill of materials to make our shopping list and to make our list of parts that we're going to manufacture. And as we manufacture them, we put this all in a spreadsheet and record, okay, so and so's in charge of manufacturing this. McTavish is going to buy these. And as they arrive, we check them off. And as they're made, we check them off. The other thing is that the gearbox plate has a part number, and that's one of our other quiz questions. So when we design a part, we come up with a name and a part number. So part names are descriptive. So gearbox plate, it makes sense. It's easy to understand what that is. The problem is that we may have different gearboxes, and so we might have different gearbox plates. And this is where the part numbering comes into play. So every part has to have a unique number, and that way we can organize things with our inventory. We can organize what we need to order, what we need to build, and it makes it very easy to keep track of things. So part numbers are really useful. You can see in our system anything that we are going to make. So part number 1 and part number 6 and part number 13, those are things that we need to manufacture. And when we make our part numbers, we have 4152, so that's our team number. Then we have a 2 or 3 digit code for what the project is. So this is our tutorial, so TUT. During competition season, this number becomes a number. And so, for example, we're going to go into the 2024 season this year, and the game is going to be called Crescendo. So 24 will refer to anything that is going to go on to our competition robot. And then other things, when we make off-season robots, we come up with a 2 or 3 digit character to represent what that is. Then we have a letter. So a P indicates that this is a part, and A indicates that it's an assembly. And then we have 0, 1. So when we create our robot, we have multiple documents. And so typically 0, 1 belongs to our drivetrain, 0, 2 becomes our bumpers, 0, 3 would be our intake. And it depends on the robot each year what kind of subsystems we have. But everything that is in the one document would have a 0, 1. Everything that's in the 0, 2 document would have a 0, 2, etc. And then the last characters are a unique number. So in 0, 1 in this particular document, basically we're going to have 1, 2, 3. We're going to have different numbered parts for each part. And traditionally, when we're manufacturing, we just stick to those last 4 numbers. We'll put a piece of tape and put those numbers on because we're typically only building one robot at a time. So it's easy to keep organized with our parts that way. Parts that we're buying, we use the part number, so that allows us to find it. So this is from Rev Robotics, so we can type that in on the Rev Robotics website, and we can easily find that part number so we can buy it. And the reason that this is useful for everybody is if you're using a motor, for example, then go to the Rev Robotics website, pull up this number, and read the documentation. So it's really important that we never assemble something without reading the documentation so we know how to do it properly, so we don't end up frying it because it's pretty expensive. Going back to our tab manager, and remember you can open it with Alt-T, we're going to filter by drawings. There's only one drawing in here. Open it up. This is our shaft drawing. And so with our drawings, this is a typical kind of drawing that we have. They're used to give us information to manufacture our part. So in this particular drawing, we have four views. We have an isometric, a perspective view over here. We have a top-down view, a front view, and a right view. So if we have a three-dimensional object, we'll typically have those four views. If it is something that is a kind of a plate, a two-dimensional object, we'll often just have the flat view of it. And then we have some critical dimensions. So those kinds of things. Now, I wanted to include a shaft view because it's really important that when we see the critical dimensions, we make sure to manufacture it. What we tend to do is cut it a little bit long, do a dry fit, and then scribe the important things and cut it, because it's easy to go, yes, this is going to be 2 and 13/64, and in reality things might be a little loose or a little tight, and doing a dry fit, we can always cut something shorter, but we can't make it longer. And that's the end of the training. So I hope you had a good time with that. Please fill in the quiz so that you are done.